Okay, so here is video 5.1. 5.1. The section is on nth roots and rational expressions. Okay, so what we're going to do is we're going to be starting a new chapter. We just finished all of our polynomial work, and we're going to talk about roots now, and also powers. And so this chapter is focusing on that. So to start us off, I'm going to talk about three different, I don't know if you want to call it a property, but I'll just talk about notation, okay? So first of all, it's a notation, but it's also defined this way, okay? So a notation and definition, there's three of them. The first one is when you see, let's see, something like this, nth root of a, okay? What you need to know is that you can convert it between the root form and the power form. So that's also equal to a to the 1 over n, all right? So if you have, for example, the third root of 8, right? That's the same as taking 8 to the 1/3 power. Okay, so this is an example. All right. So what's helpful about this is because sometimes some calculators will have a square root. Well, most calculators, scientific calculators, have a square root. Some of them might have a third root, but as we get to higher numbers, like maybe if you had to find the sixth root of something, you don't have that button on your calculator, you can type it in as 8 to the 1 over whatever root you're looking for, because every single calculator has an exponential button. All right. So that's the first thing I want to kind of describe for you. By the way, in this case, what this means is that we're looking for the third root of 8. So what number do you know of where multiplied 3 times by itself will give you 8? Well, in this case, we know that 2 times 2 times 2 will yield the answer 8. All right? On a side note, though, let me go ahead and add. Okay? There's a little bit of a side note here, so I'm going to write a little note. Okay? When you have n, okay, so when n is odd, okay, then you have one answer, okay? You have one case. Answer is one case, and I'll explain what that means in a second. When n is even, then you have two cases. You have your plus and your minus case, okay? So in this case right here, there's only one number, positive 2, that multiplied by itself 3 times will give us positive 8, okay? Now a second example would be if you have 16, the fourth root of 16, okay? So again, we can rewrite it as 16 to the 1/4 power, okay? And so what we're asking here is what number can you think of multiplied by itself 4 times will give us 16? And your immediate answer would be 2 times 2 times 2 times 2, 2, 2, 2, 2, that equals 16. The other answer that you need to consider is negative 2. Okay, so because we have negative 2 is positive 4, times negative 2 is negative 8, times negative 2 is positive 16. That's why we have a plus and minus case whenever our n right here, okay, is even, all right? And then if it's odd, like in this case, we only have one case. If this was negative 8 in here, the answer would be negative 2, but it can't be positive and negative 2, all right? So that's notation definition number 1. Number 2, something you will encounter is if you have a combination, okay, of a power and a root, okay? And what this tells you is that when you have a to the m over n, okay, just like we have our factor here that was moved to the denominator, we can likewise move it to the front into a root. So this is equivalent to the nth root, so this value here, let me use another color, this value here, okay, can be represented as the root. So it can be rewritten as the nth root of a to the power of m, okay? So you can go back and forth between these two notations, all right? Also, on the side, I believe you may have learned that if you have a negative power, okay, I'll put remember. I don't know if you remember, but I think you should know this. A to the negative m. If you have a to the negative m power, you can rewrite this as 1 over a to the m. So you can get rid of the negative by throwing the a and m underneath the 1. So you can write it as a denominator. So likewise, that information leads us to the last bit of notation. So we have this first one right here, where you can change the nth root to a power of 1 over the n. You have this notation right here, where you have a to the m over n, and you can rewrite it as the nth root of a to the m. And keeping in mind that whenever you have a negative exponent, you can write it as a denominator under 1, okay? So if you have a to the m, negative m over n, you can rewrite this as 1 over a to the m over n, which we just said over here was the same as 1 over the nth root of a to the m. Okay, so this is a third kind of notation or definition, kind of using multiple properties. Just to know that these two things here are equivalent. Whenever you see something like this, you can rewrite it and get rid of the negatives and also the fractions by rewriting it like this. I guess you get rid of this fraction, but you put it into a different form of fraction. So let me go ahead and give you a quick example of how all this kind of interplays together. All right, so let's just go ahead and say, and I'll squeeze it over here so I don't have to erase everything. Let's say you have the following example, okay? You needed to evaluate 8 to the negative 2/3 without a calculator. So there are some problems where they ask you to evaluate with a calculator, and some problems that they ask you to not use the calculator. And this one is easily doable without, okay? So if you have 8 to the negative 2/3, okay, we can get rid of that negative exponent by rewriting it, like just I said here, as 1 over 8 to the 2/3, okay? And if you don't like that exponent as a fraction, you can rewrite it as 1 over third root of 8 squared. Well, 1 over the third root of 8 squared is 1 over the third root of 64, okay? So now we have to stop and ask ourselves, if we want to clean this bottom part up any further, what number multiplied by itself 3 times, so it's an odd, so there's only one case, what number multiplied by itself 3 times would give you 64? And so because there's one case and the item inside the radical is positive, it's going to be a positive answer, and the answer is 4. Because 4 times 4 is 16, times 4 again is 64. So instead of writing this, it's equal to 1/4, and that would be your answer after the evaluation.